Our today's topic is modular arithmetic. And the modular arithmetic is other way of performing arithmetic, or adding, subtracting, multiplying and dividing number, and by using a constant difference. Especially when you want to add a number, and you are adding a number by rotating a number in a positive integer in a circle. Take for instance now, let's say you are having clock. You are having clock and you want to calculate days, hours in a day. You know, a clock starts from, you have 12, 1. Here you have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say you want to determine time. You will find let's say you have 18 hours. Somebody is saying you should determine the time it will be if you are counting in an 18 hours on a clock. No, from here you can start from 0, which is your 12. 0 here, you can start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you get 12, the remaining 6 you still go like this. 13, 14, 15, 16, 17, 18. That means if you have 18 hours, it will show exactly. Starting from here, you go round back to this 6. So this 6 will show counting or arithmetic for 18 hours using the what? The clock, the sign of the clock. So when you are counting and you are moving with a positive integer or number in a cyclic form, is what we refer to as modular arithmetic. So it's a way of adding, subtracting, or multiplying number, or performing arithmetic operation in a repetitive form. So that's what I mean by what? Modular arithmetic. Let's just simply write something on that, on modular arithmetic. Let's look at modular arithmetic. In the modular arithmetic, we can say it is of this is a form of arithmetic. This is the form of arithmetic of counting positive integer round is circle. So we having come up counting the positive integer round a circle with concentration on the remainder, with concentration on the remainder, with the concentration on the remainder, is referred to as modular arithmetic. So the form of which you are performing the arithmetic is referred to as modulo. Modulo, or can just say modulus. So modulo is a form of what the base of which you are performing that arithmetic operation. So in this place, let us see how can we simplify expression or performing arithmetic expression in modular arithmetic, and that one will now take us to this kind of example. Let's look at this example. Let's see how we can perform modular arithmetic in what? In performing a certain expression in modular arithmetic. Let's look at this. You can say reduce Let's look at this. We can say reduce 58. You can say reduce 58 to a simplest form in modulo of 1. You can say modulo of 4, 2, modulo of 5, 3, modulo of 6. Let's see how we can perform modular arithmetic in the following modulo. When I say modulo, it means the form of which you are counting or you want to reduce an expression. The first one, we have 58. So we want to perform it in modulo 4. Let's say in modulo 4. In modulo 4. What we are going to do is, we are going to say 58 equals to, how many? You can express it as 58 divided by 4. How many number of 4 can you find in that 58? You say 5 here, we have 1, remaining 8 in 18. You are going to see 6. So you can say our 58 is 4 times 16 plus. So because you can say 4 times 16 is 4 times 8. 4 here, 1 in 18. No, 4 in 18 we have 4. Sorry, we have 4. 4 times 1, 4 times 4, 6. 4 times 4 we have 16. Mean that 1. 4 times 1, that is 56. So we are going to see 14. I'm going to see 14. 4 times 14 is 56. And we take 56 away from 58, we remain that 2. So we are going to have modulo 4. And then that means, what this one means that in 58, you can see 14 in 58, that's why I have 4 times 14. Plus 2 there means remainder 2. So under the counting in modulo, so we are going to give it what? Remainder. That's what we want to say. Counting in a positive integer, round a circle with a concentration of what? On the remainder. So our remainder here is 2. So our final answer will be 2 modulo 4. Our answer is 2 modulo 4. So anytime you are asked to find a modulo, you are going to use that number, which is modulo, to divide. So that means anything as that number 4 times 14. Then what? Remainder plus remainder. And then your final answer, you are going to express as well, remainder. So we concentrate on remainder in a modular arithmetic. Okay, let's look at a second one. In second one, we are operating in what? In modulo 5. In modulo 5. In modulo 5. To operate in modulo 5, you are going to have 58 equals to, you will say how many 5 can you find in 58? You can probably do it somewhere here. 5 here, 1. 5 in 8, you have 1. That means you are going to see 11. So you are going to see 11. 5 times 11, that's 55. So you are going to express your 58 as 5 times 11. So we have 5 times 11, 55. Subtract 55 from 58, remain what? Remain 3. That is remainder 3. Like this. Modulo 5. So, and your final answer is going to be what? After you are saying how many 5 can you find in 58, you have 11. Remainder 3. So your final answer is going to be 3 modulo 5. So that means we concentrate on what? On remainder. That is your answer. That's what we will reduce. We are able to what? To reduce 58 into remainder 3 for modulo 5. And we are able to what? Reduce 58 to what? To remainder 2 under modulo 4. Okay, let's look at another one. Third one. In modulo 6. In modulo 6. Let's look at another one in modulo 6. In modulo 6, so you can have 58 equals to, So the first thing to do is what? Let's divide by 6. Let's see how many 6 can we find in 58. You have 58 like this, divide by 6. So we can say 6 in 58. I think you can see 6 times 9, which is 54. 6 times 9 will give us 54. That means you can get what? 9. Then subtract 54 from 58. Remainder 4. So that means you can express 58 as 6 multiplied by 9 plus 4. Because 6 times 9 will give us 54. Plus 4, I'm going to have 58. So in modulo 6. Modulo 6. So your answer will be remainder. So that means you can get, what this one means is that in 58 you can get 6 in 58 you can get 9 and remainder 4. So you are going to write your remainder. So our answer is 4 modulo 6. 4 modulo 6. So we are able to work to reduce a particular expression given in what? In modulo 4, in modulo 5, and in modulo 6. So modulo is just like a base of which you are performing arithmetic operation. Anytime you are performing arithmetic operation, we concentrate on what? Our remainder. So you are going to write your remainder down as your final answer. Okay, let's quickly look at the table of modulo. You want to look at table of modulo. How do we quickly, before we look at how to add number, how to perform addition, multiplication, and subtraction in modulo. So let's quickly look at this, the tabular form of this modulo. Let's look at addition. Multiplication 2. Addition modulo 5. If you are saying a number is in modulo 5, that means you are counting number from 0, 1, 2, 3, 4. That is what they mean by modulo 5. I think you move around 1. So if you are given 8 now, that's somebody saying you should go, you are given 8. You should express a modulo 5. It means you will move around. You want to count 8. What's going to be given in modulo 5? You move around from here. 1, 2, 3, 4, 5, 6, 7. That means 8 will be your final answer. So that means modulo 8 in modulo 5 will give you 3. So if somebody is saying you should get what? 10 in modulo 5. That means you move around. Let's count. If you are getting 10 in modulo 5, start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 10 in modulo 5 will give you 0. The money is saying that 12 in modulo 5. What is it going to give you? Let's move around 12. From here, you count from start from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means your answer will be 2. So if you are counting number and moving around in this positive side in the circular form, is referred to as modular arithmetic. So it depends on the what? The modulo, I mean the base of which you are performing the operation, whether in modulo 5, 6. So that is what they mean by in modulo. Okay, let's quickly now look at the modulo 5. If you want to perform an operation, how do we add addition of modulo 5? So for modulo 5 in the tabular form, it will look like this. So you are going to arrange your number. Here you have your plus, modulo 5. So you have, here you have your 0, 1, 2, 3, and 4. Likewise, here you have your 1, 2, 3, and lastly 4. If you are performing operation, especially addition in modulo 5, don't forget modulo 5, we have a digit from 0 to 4. Let's perform operation in modulo 4, in modulo 5. Let's add. 1 plus 0 will give you 0. 1 plus 1 will give you 2. 1 plus 2 will give us 3. 1 plus 3 will give us 4. 1 plus 4 will give us 5. Once it is 5. Since it's modulo 5, and modulo 5 contains the what? It is from 0 to 5. So you are going to use the modulo to divide. You will divide by 5. What will you get? You get 1, remainder 0. So we always write remainder. So you are going to put 0 here. So move to the second column. Here you are going to have 2 plus 0, you have 2. 2 plus 1, you have 3. 2 plus 2, we have 4. 2 plus 3, 5. Since it's 5 divided by 5, you have 1 remainder 0. You are right, remainder 0. You always put down your what? Your remainder. Don't forget. Here, 2 plus 4, you have 6. Divide by 5. 5 is 6, you have 1 remainder 1. So you are going to write remainder 1. The same thing. Okay, 3 plus 0, we have 3. 3 plus 1, we have 4. 3 plus 2, we have 5. Divide, you have 1 remainder 0, you have remainder 0. 3 plus 3, we have 6. Divide by 5, you have 1 remainder 1. 3 plus 4, we have 7. Divide by 5, you have 1 remainder 2. Likewise here, 4 plus 0, here we have 4. 4 plus 1, 5. Divide by 5, you have 1 remainder 0. 4 plus 2, 6. Divide by 5, you have remainder 1. 4 plus 3, 7. Divided by 5, we have remainder 2. And lastly, 4 plus 4, we have 8. 8 divided by 5, you have 1 remainder 3. So you are going to write your remainder 3. This is what? A table for modulo 5. Addition in what? Of modulo